Okay, so on this last part of this Lecture 2 replacement online lecture, we will be talking about agile approaches into software development. On the earlier parts, I discussed the waterfall model and on the second part, I talked about the other models such as prototyping or iterative models and such. But I also mentioned that there's an entire other genre of software development process models called agile approaches, and this is the thing I'm going to talk about on the third part of my lecture. So basically the agile approaches are based on the Agile Manifesto from year 2001. The idea on these agile approaches was that the existing software process models were simply too complicated and extensive or laborious to be actually usable by software companies. So the idea was that the process model could be made more lean or more responsive to different problems that arise during the software development, instead of being prepared for every possible problem that we might identify as a risk. Of course, the agile approaches aren't that new idea. In fact, the agile approaches reach back almost as long as the waterfall model. Basically, the first agile models were introduced at the same year than the waterfall model was, in the 1950s. But the current agile approaches, such as extreme programming, XP, or SCRUM, which is really popular nowadays, are something that's developed in this lean approach renaissance, starting from the Agile Manifesto of 2001. So basically the manifesto says that the individuals and interactions should be emphasized over processes and tools, and working software is the only reasonable measurement of work, instead of comprehensive documentation of what we have planned or what we are going to do. The customer collaboration, working with the customer instead of making a deal or business agreement and then having contract negotiations, is also the third main idea of the Agile Manifesto. And finally, being able to respond to change over following a pre-made plan are the core values which the Agile approaches promote. Obviously, the Agile approach, which says that we should be responding to changes instead of following a plan, or having working software instead of comprehensive documentation, doesn't mean that we are not going to do planning, or that we are not going to manage risks, or that we are going to do just what we want. I want to be very, very clear on this aspect. The cowboy coding is the term we are looking for when we are in contrast of actually using some sort of development method. The cowboy coding means that the developers do what they feel right or what they want to do, or solve any issue the best way they see fit, even though it would be hindrance on the larger scale. So basically this is something, the cowboy coding is something that goes back into the early 70s, 80s, or early ages of software engineering, where the software developers were the artist warriors who were making some sort of a magic with the computers to solve problems that the computers were meant to solve. So basically, the cowboy coding is doing something just by so to say, playing it by ear. It may work on small tasks and in really small projects, but in larger effort, which the agile models are also aimed for, it simply doesn't work, because you cannot manage or operate a crew of 10 to 15 people without having some sort of plan or management, or even designs or schedules for who does what. So, instead of cowboy coding, I'd like to say a few words about the suitability models. Of course, this is also a gross simplification. The idea that the agile models are more suitable in reactive development or adapting to the problems that arise instead of being prepared for everything based on risk management. It also means that we can more or less say that if we are doing something that's critical software, meaning that the outcome or failure of the software will kill operator or passengers or people relying on the system, such as in medical equipment or in or with airplanes or with military systems actually, of course we have to have more planning work and we have to have more risk identification activities. On the other hand, if we are just doing something like a video game or some simple software or Facebook application, we are not killing anyone if our software fails to work. So we might be able to get away with less design and just reacting to the problems that arise during the development. So basically the model here gives sort of an idea that the amount of design or planning or preparation in one-dimensional scale, meaning that, for example, something like extreme programming is on the other hand, and here the hackers mean basically the cowboy coders here, and there's also adaptive software development models such as SCRUM, the milestone risk-driven models or plan-driven models, more or less something like the rationally unified process, and the inch pebble iron-bound contract, which is something that reflects the deals that the governments or military tends to make. So anyway, the suitability model is really crude. It's obvious that the agile project models are more suitable when you have small crew, small criticality, have to react to changing requirements such as the customer preferences, and if you aren't completely sure what you are doing, then you probably are more familiar or more home in a process model that allows making changes or allows doing some quick thinking on your feet. So for the rest of the lecture I'm going to go through two of the most representative agile models I've come to think of. The first one is extreme programming. It's not that much used in its purest form in the industry, but it's something that's very, very different from the waterfall model, so it gives you a contrast between the traditional waterfall approach and the agile approaches. Then I'm going to talk about SCRUM model, which is a model that is really popular with software industry. At least based on our studies in Finland, almost all game companies, for example, use SCRUM as their model, and also other companies developing phone applications or even phone platforms tend to use SCRUM simply because it's something that's agile or adaptive, but it's not that rigid or difficult to work with. So anyway, to go into the first model, the extreme programming is something that was developed by Kent Beck, Ward Cunningham and Ron Jeffries. Kent Beck is also developer of other agile approach, test-driven development, which is actually more or less more refined way of doing small software or software systems where you are already able to establish your software quality or unit tests when you have the source code done. So Kent Beck is someone who has done extensive work on agile approaches, agile methods, and he is also really reassuring person to know that this model is more or less based on at least few good ideas. Okay, so the objective of extreme programming is, well, not to be formal or at least believable name. I personally hate the term extreme programming because it's so juvenile. But let's say that the XP is actually something that aims to have small teams, ability to work with customers, uses automated unit and function testing, and it aims for high quality in software projects which are which have manageable size, meaning that the software is something that can be built by the small team of 2 to 12 programmers in one environment and working with the customers so that there's an easy way to share knowledge and talk with the customer if there's some problem or you have to have more definitions or activities. So basically the XP project goes like this. You do architectural spike here, meaning that you do planning work for what sort of system you want to have. You collect the user stories, which are the requirements and the test scenarios. When you more or less know what sort of architecture you will be using, you'll start to do release planning or releasing work by doing a plan for next iteration, development, and then seeing how the for the features, and then do the iteration between the latest version, acceptance tests, bugs, next iteration. So basically you are continuously planning new features and also developing the software forward. So, and when you are done with your one release or one new version, you have the acceptance tests and the customer approval, so you release that version. I aren't releasing anything in a, let's say, monthly cycle or even weekly cycle. The small release here means that every time you add new feature and have that feature accepted and approved, that's your new release version of the software. So basically you are continuously developing your software like in some form of incremental development, even though unlike other models where the milestones may be 1 month or 1 week apart, in extreme programming or XP, the idea is that you have one version every day or as soon as it's available. So a couple of words about the different phases. So the planning work is more or less similar to any other project. You write user stories, which are use cases or more or less requirements. You make schedules. You may plan your schedule so that you make frequent small releases. You do project otherwise in iterations, and you plan new features or what you will be doing on this iteration on start of each iteration. Move people around so that people are available to see the system from many different angles, and start your day with a stand-up meeting so everyone knows what other people will be doing today and what will be happening for the rest of the day or rest of the week, or at least a couple hours forward. So, and on the design, you do simple things. You try to make it as simple as possible. This is not a model which uses refined or really sophisticated or complex approaches. If you can do something simple, then you should always choose that approach. So basically, you reduce risks by using simple approaches, and the spike here, meaning this one, create spike solutions to reduce risks, means that you create one solution, see if it works. If it works, you incorporate or integrate it into the system. Otherwise, you have to come up with a different solution. And when you are able to, refactor your code, meaning that rewriting entire module in a more simplified form, then you can also do that because it makes the system more coherent, more refined, and also usually tends to get rid of some bugs that the system will have when you are approaching things with this sort of approach. Okay, so code work, well, there's a quite usual list of things here, really. You have to have the customer available, and you have to have writing standards or agreed guidelines on how the code will be written or commented, and that should follow some standard. You start by making the unit tests, and that's actually something that's also in the test-driven development. Do programming work in pair program approach, meaning that you will always be working with your colleague so that you can bounce around ideas or check each other's work, and you do instant integration, meaning that you always integrate your unit, your module into the system to see that it also functions outside your unit testing environment. The optimization work is something that's done after the system works, and the interesting part here is the no overtime part. In extreme programming, the idea is that it's so exhaustive approach into development, so you should not be doing overtime simply because your output isn't as good after 7-8 hours of work, continuous work, as it would be if you are rested and have frequent breaks or lunches or ability to rest every now and then. So, testing in extreme programming is, it follows the same pattern, really. All code must have unit tests. All unit tests have to be passed. When you find a bug in an existing system or the latest version, you instantly create a test to get rid of that bug in the following versions, and basically you are doing test-driven development whether you like it or not. So technically, the idea here is that there's not one person owning any part of code. You are doing pair programming, you move people around to help each other, you refactor your code at every possible occasion, and do continuous integration, and you should always have 100% unit tests passed. This means that when you are sending something for acceptance testing, you should always be certain that the technical aspects of the program works, but the customer may want to have some other changes, like changes on the interface or something like that. And to summarize the whole approach, the idea is that you get always feedback on every feature. Your colleague gives you feedback and planning information on your continuously as you do the programming work or development. Your unit tests ensure that your program stays intact. That's the feedback by every couple of minutes. You negotiate your approach to problem with your partner or your colleagues. That gives you feedback every hour. You start your day by having a stand-up meeting so that everyone knows what everyone is doing, and that gives you feedback once per day. Acceptance tests when you are done with some feature gives feedback or information every couple of days. The iteration plan, meaning that you are planning ahead on what we will be doing on next couple of iterations or next couple of weeks, will give you information, and the release plan gives you monthly information on how things are going. So basically, this way you aren't doing that much planning beforehand. Most of the planning happens on the iteration, release plan, and on these pair negotiations here. But you still get enough feedback to know what works and what needs refactoring or revisit on the planning, from the planning point of view. Okay, so that's quickly the extreme programming. It's something that's really different from the waterfall approach, but it's actually also something that tends to work for small projects. It's of course understandable that if you are doing something that's quite small in scale, For example, if we are honest here, mobile games aren't that huge of a project. You can do the technical design with quite small amount of documentation, and more or less because you are developing something for people who have a fiddly imagination and have changing preferences, you more or less have to be prepared to make changes on your entire product. I'm not saying that the game development isn't difficult or complex or complicated, or that it wouldn't be difficult. Of course, it's software development as a part of business work, it's always difficult. But if we talk about really large information systems or resource planning and management systems, we are talking about stuff that has more variables and components and modules than the space shuttle had. So basically, the largest software projects design something that's in the scale of space shuttle, whereas on these smaller projects we talk about something that can be done with quite small amount of documentation. So obviously there's room for different approaches. Okay, but that's enough about the extreme programming. We also have the other approach, SCRUM, which more or less incorporates different things from extreme programming and the more traditional iteration or waterfall approaches. So basically, the SCRUM is an agile project framework. It has a couple of features. For starters, the SCRUM approach has more project management aspects than the extreme programming. The sprints or iterations take 2 to 4 weeks, and we manage our artifacts or requirements or features by having backlogs or sprint backlogs or burn down charts to follow what we are doing, what we have done, what we are still missing, and what features work. We have a couple of defined roles here, which more or less are the people saying the final word, the people managing the entire development, and the team doing the development work. And of course, we are doing planning meetings at every start of the iteration, daily meetings to ensure that everyone knows what we are currently doing, and review meetings to see what sort of stuff we still have to do or what we have to incorporate into the later iteration models. So basically, our approach is this. We have the requirements in packages, which mean that each package is something that can be done on one cycle of 2 to 4 weeks or 1 month. And we take the first package, add it into the requirements or things that we are currently doing, have 30 days cycle to develop those requirements from that work package, and during that 30 days we are doing daily Scrum meeting to see where we are. If there's things left over, we might want to do some backlog burn down iteration where we are just doing things from the existing packages or some other things. Some other things like quality assurance or quality control or simple testing iterations where we use one cycle to just see that everything actually works, or where we are refactoring code and seeing that everything still works. Take notice though that the Scrum model has no say into how the requirements are collected. We just get the requirements from somewhere. This model doesn't take or say anything about where the customer is or how we ended up with these requirements or work packages. It's just something that we have to do somehow, and because the Scrum model only talks about the development work. Collecting requirements or managing launches or managing upkeep is something that you should design separately, because when the cycle is over, every testing is done, then you have the latest production version of the or the latest deliverable version of the product. So going into the couple of things here. Yes, the project is split into less than 30-day iterations called sprints. It means that you should have 30 days to get one major feature or one activity done into your work. Also, one sprint realizes one set of new requirements, including design, implementation, and testing of the set requirements or the features, meaning that after you have launched your new version, you should have something that functions again. And of course, if you are running out of time, then you have to add those things into backlog and do a separate sprint to catch up with those things. And like I said earlier, you are allowed to do quality assurance sprints, which more or less are meant to see that everything works and doing refactoring work on modules or quality assurance and other things to ensure things still work. Well, couple of things or terminologies mentioned here. The product backlog is more or less the prioritized list of requirements, stories, features, and other things we have to do to our software. The sprint backlog is a list of things we are doing in the current iteration, and the burn down chart is the chart which says what are still left, what items are still left on our sprint. The developer roles, the product owner is the one who defines the features and is responsible for the business aspect. So the product owner is the person saying final word on almost everything here. Whereas the Scrum Master is more or less the project manager who runs the project to get things done. The team, well, the team is the rest of the guys or girls, and it's the developers, the designers, the artists, the testers, the pizza delivery man, and basically all the other people who are related into the project. And the ceremonies, of course, are more or less just a word for the different meetings and reviews and stuff like that. The planning meeting tells about the discusses about the next iteration. The daily meeting is 15-minute meeting of the start of the day where we talk about what we will be doing, and the review meeting is something that where we discuss what we achieved during this iteration. So, in a more or less a summary, if we go back or add the ideas of the Scrum model and put it against this iteration model, here we see that there's actually several similarities. The initial planning or planning work in general in Scrum comes from somewhere, but the idea of analyzing what we will be doing on this iteration, doing the development work, doing the testing work, and seeing how it functions is actually something that's completely similar to Scrum. This is something I'd like to point out, that the difference between the agile approaches or the plan-driven approaches isn't that large. This iterative model here, well, what I was talking about in the plan-driven approach, is more or less the same than in the Scrum model, but the philosophy or the idea is somewhat different. One does the business modeling and all the planning work or prototyping work and stuff before going into the development, whereas the other approach does the only crude idea or planning stage before going into development work. And when it stops when we are satisfied with the product. In iterative model, you deploy the software to customer. In a more agile approach, it means that you have the new release version available and you have a couple of new features you want to show to your customer. So considering the entire chain of actions from the initial idea to the developed, deployed and software that's available for your customer, nevertheless, the software process model, you have something like this. You have customers, You have users, you have people who would be willing to give you money about something. You collect the requirements, and based on the requirements you create the analytical architecture, or the idea of what you should be doing. Based on that, you select your hardware, you collect your actual architecture, the components that you actually need. Based on this more defined architecture, you create the source code, and then you deploy stuff when your source code is functional. Of course, you have to do testing work and that sort of stuff. But technically, these are the steps that you always have to do. You have to have the customers who pay for things. You have to have the requirements which define the software. You do the analytical architecture, which more or less is the way to answer to all the problems imposed by the requirements. From the analytical architecture, you go to the actual architecture, which includes all the restrictions and things imposed by the applied hardware or the technologies and stuff. And then you have to do the coding work, development work, and after you are satisfied with your outcome with the development and quality assurance works, then you deploy your software. Okay, so I'd like to close this lecture with one picture. This is a delivery project in practice, meaning that this is a collection of different things that have actually affected how the project was, one software project was done. And as you can see, it's not waterfall, it's not iterative model, it's not the generic model of the last slide, it's something huge. And in practice, you have things like marketing or pre-studies or offers or contract negotiations here and there, and even the training, deployment and implementation can be different projects. So what you end up doing in real life is not only more complicated than this, it's more complicated than this, and especially it's way more complicated than this.